Greetings everybody. So I want to make this video to introduce some of the important vocabulary for statistics. But in addition to doing that, I think in this one video, I'll be able to summarize what so much of the study of statistics is about. So here goes. So first two terms I think everyone needs to know is what is a population and what is a sample. So in order to explain all this vocabulary, I'm going to give this example that I hope is really easy to understand. Okay, so try to use your imagination and imagine that we have a jar and within it is an assortment of blue and green marbles, just like you see. Some are blue, some are green. And imagine, once again, just use your imagination, try to think that we wanted to do this for whatever reason, and that we want to know what portion of those marbles is blue. Okay, all right. Now that right there, the jar with all the marbles in it, is a population. Okay, so a population is the entire set of individuals, items, things, or numbers that we want to study or know something about. Okay, so the jar of marbles that we want to know something about, such as what portion are blue, that's the population. Now, how do you think that we could learn something about what portion of marbles in there are blue? Well, one way that we could do it is we could reach our hand in there and grab some marbles off the top and get that handful and then look at the handful and see what it's like. Okay, so suppose we do that. That handful, the marbles taken from the jar, okay, that is called a sample. All right, the sample comes from the population somehow. It's not necessarily that you're going to have a jar and a handful, but anytime that you have some population that you want to know something about, and then you take some of that population and look at it, what you take is the sample. All right. Now, you might even say that from there we could look at our handful and see what it's like. In this case, I see 3 out of the 4 marbles is blue, and so maybe we could say something like 75% of the marbles are blue. Okay, so that little experiment, okay, that idea is how I'll get across to you the idea of a population and a sample. We want to study or know something about the population. The way that we do that is we take some from it, and what we take is called a sample. Okay, all right, now from there, this will take us a little bit further. Because we could talk about different kinds of samples. Because in my example that I just gave you, we had the jar and we wanted to study what's in the jar, and we reached our hand in and we took some off the top. Okay, so in this case, there is going to be something called sample bias. All right. Okay, so think of it like this. If I reach in to the jar and take a handful of marbles, there's no guarantee that what that handful is like is going to be what the jar is like. Okay, so in my handful, 3 out of the 4 or 75% of the marbles were blue, but that doesn't mean that's what the jar is like. Okay, we want our sample to be as much like the population as is possible. Okay, now in my case, me just reaching into the jar and taking some of the ones that are on the top, that's called a convenience sample. Okay, and the fact that it probably doesn't represent what the jar's really like because I just took the ones on top. Like, what if there were, for some reason, the blue ones had settled to the bottom or the green ones had settled to the bottom and they weren't mixed all the way through. Okay, they were kind of clumped together. Well, this convenience sample wouldn't represent the population, and whenever that happens, whenever a sample does not represent a population it's taken from, we say that it has bias. Okay, now when we study statistics, when we do statistics, we would like to avoid the bias as much as possible, because the whole idea here is that I can take a sample and it tells me about the population because it's like the population. All right, so okay, so yes, samples could have bias. A sample might not be like the population that it comes from. Okay, sample bias is often difficult to avoid in practice, but in general, we want the sample to be as much like the population as is possible. So in my case, that's a convenience sample. What would be an improvement on a convenience sample? What may have a lot less bias is something called a random sample. In a random sample, every member of the population has an equal chance of being selected. So when I took this handful of marbles out of the jar, not every marble in there had an equal shot at being taken by me. Only the ones at the top have an equal shot. The ones at the bottom have no chance. In a random sample, in a good sample, then every marble in there is equally likely of being selected for the sample. Okay. Now, how could we do that? How do you think we could collect a random sample? So I'll show you something. Here is a video of the first Texas lottery drawing, and I notice here they have a machine that mixes up the lottery balls that have different numbers on them as they're selected. So imagine if the people just reached their hand in there and took some, and there'd probably be all kinds of accusations of bias. Okay. So, you know, maybe something like that would allow us to do this. Okay. If we could mix those up and then they kind of randomly fall out, then that would be probably closer to getting a random sample and probably closer to removing some bias. Okay. All right. Another thing that could come up is this number that we get about that handful and the bias to the population. Okay, so I did say that 75% of the marbles in the handful are blue. Does that mean that 75% of the marbles in the jar are blue? Probably not, because there's sample bias. All right, so let's talk about the number 75%. Okay, there's a term for just that number that we need to talk about. So let's talk about parameters versus statistics. Okay, so remember, we've got the jar and we want to know something about the jar, and the way that we do that is we take this handful. The handful is called a sample, the jar is called a population. Okay, there's bias between the two of them because the handful is probably not entirely like the jar. So yes, we've established already that I took a handful of marbles out of this jar, and it happened to be, after I counted them up, that 75% of the marbles in the handful were blue. Okay, and I was saying that, well, it's probably not true because of sample bias that exactly 75% of the marbles in the jar are blue. Okay, now those numbers, the percentages either way, have names. Okay, 75% of the marbles in my hand from the sample being blue is called a statistics. Okay, so a statistic describes something about the sample, such as the percent in the sample of blue marbles. It could be also the average weight of the marbles in the sample or something like that. Anything you could measure about the sample is called a statistic. Okay, so in my example I've been using through this whole video, 75% of the marbles being blue in the handful, in the sample, that's called a statistic. Okay, now use your imagination and suppose that in reality somehow we find out, or somehow we know when it's all over, that within the jar 60% of the marbles are actually blue. Okay, yeah, why is 75% different than 60%? Well, because of sample bias. The sample does not always represent the population. But if in reality 60% of the marbles in the jar are blue, then the number 60% is called a parameter. Okay, so they seem like they're the same thing. 60% are blue, 75% are blue. But because 75% refers to the sample, it's called a statistic. And because 60% refers to the population, it's called a parameter. So you see the difference between a statistic and a parameter. Our hopes would be that when we do statistics, when we have experiments and collect data, that the statistic is very close to the parameter, because the parameter is actually what we want to know. But it may not be, okay, because of sample bias. Now, all right, now say we've done all this. I've introduced the terms. I've had this experiment with the marbles to go along with all of it, so you can have something to think about. One thing that you might have thought already, or thinking at this point, is if we wanted to know from the beginning how many or what portion of the marbles in the jar are blue, why not just open the jar, dump them out, and count them, because then you'll know, right? Why just take a handful out if it can be misleading? If the sample might not represent the population, why do it that way? So the reason that we take samples in the first place, even if it wouldn't be practical for this jar, okay, this jar is just something that's supposed to be simple for you to think about. In my example, the reason that we study samples at all is because what if the population is gigantic and very difficult to study on its own? I know you could just dump the marbles out of the jar and count them in a jar like this, but the population could be enormous. So here's an example. I see this kind of thing all the time. If you look for it, you'll see this kind of thing all the time too. So in the news, I came across this today about some study where reading for pleasure is down 40% among Americans. Now, I'm an American. Nobody ever asked me how I rate reading for pleasure, okay? Nobody ever asked me what I think about reading for pleasure, and probably nobody ever asked you either. So how can they say something like this? Well, it's just a sample versus a population. So there's all of America and how people in America feel about reading for pleasure. And then there's the small subset, the small collection, the small group of Americans that were asked about how they feel regarding reading for pleasure for this study, okay? So maybe they did something like this. Maybe there was a poll, okay, among, I don't know, 100, maybe 500, who knows? There was a poll among some manageable number of Americans where the researchers asked them questions to figure out how they feel about reading for pleasure. They did not ask every single American how they felt and then make some conclusion that way, because that's completely impractical. There's just too many people. But among a sample, yeah, you can study the sample. You can collect a sample, a small number of Americans, ask them how they feel about reading for pleasure. And then if you believe, in addition to that, that sample represents the entire country as a whole, you could make this conclusion. All right. So that's why that even though in this example that I've used here, it seems like it'd be pretty easy to know what portion of the marbles in the jar are blue and there'd be no need to take a sample, it still provides a good example to help you understand how studies and data and statistics are done in general.